Initially, I want to make my honest confession that my area of research is not the power engineering or power science. I'm actually belonging to the AI machine learning domain. So I will give you some idea in this area, that is the renewable energy forecasting using machine learning and deep learning. So I have already, the Professor Sudeshna Sarkar has already presented some basics of AI. So I can recommend you that she has a NPTEL lectures on AI and machine learning. So if you are interested in machine learning, you can follow his lecture on the NPTEL. It is a freely accessible. So okay. So now you are expert in energy and also the power. So if you know that the energy in a generation is mostly comes from the fossil fuels, and also you know the impact of that kind of power generation on the environment, and you also know, you're familiar with the greenhouse gas effect and also environmental pollution and how it is affecting the global climate. So now we have to look for the sustainable development for meeting the present needs without compromising the chances of future generation to meet their needs. So one of the drawback of the existing energy generation system that is dependent on the fossil fuels, it is already known to you. So we need to explore the renewable energy sources, and renewable energy sources that are actually the alternative supplies for the future energy management. So why we should focus on that? Because it is clean and it is green, and it is also beneficial for the protection of the environment. So all of you know that there are different sources of renewable energy: hydropower, biogas, geothermal, wind, and solar power. So one of the important problem in renewable energy forecasting is the uncertainty. And you know the uncertainty comes from the high fluctuation and unpredictability of the renewable energy sources, say the solar energy or wind energy. You know, the uncertainty in wind, uncertainty in solar, sunlight. Due to this fact, there is some uncertainty in the renewable energy sources. So now, if we are actually, how our system can be customized, how our system should be integrated with the renewable energy renewable power. So the point is that due to this integration, so if the forecasting can be done accurately, particularly the short-term forecasting can be done in a short time, then the power grid operator can operate the grid in proper way, and that can minimize the production cost also. So I have limited knowledge in that power domain. So how it can be actually integrated in reality, that is the topic of research. So now I am going to so what was the actual different types of algorithms which is actually applied for the renewable energy forecasting? What were the earlier methods before deep learning or machine learning? So earlier methods were the physical methods and the statistical methods. The physical methods actually depends on some physical laws, some equations, and say for example that you know that a Doppler effect. Doppler effect is nothing but a that can be represented by some equations. So that was actually defined by some mathematical equations. And a statistical method, say, for example, autoregressive integrated moving average. There is an ARIMA model that is very popular in forecasting domain. So autoregression means it is nothing but a regression that predict the current value depending on the past values, past y values. And it is actually the combination of the two module, and second module is the moving average. The moving average is actually used to smooth the transition of prediction. So by combining this model, both model, the ARIMA model can be actually applied. But one of the drawback of this ARIMA model is that is actually dependent on a single variable. But sometimes the forecasting does not depend on the single features or single variables. And so we have to depend on the machine learning and deep learning methods, which is my today's focus. So what are the drawback of the physical and statistical methods? So it does not work well for the non-stationary data. Non-stationary data, it does not work well for the cases where the data is a high dimensional and the relationship between the input feature and output is complex and nonlinear. So in that case, this physical and statistical method is not actually, the existing method is not applicable. Just to look at the figure, you will see that this is a stationary data. It is periodic in nature. And so, it is a mean, what is called the stationary data. Stationary data means the mean and variance is constant. But in case of non-stationary data, the mean and variance is not constant. It is variable with time. So for the non-stationary data, the ARIMA models that I have mentioned or the statistical existing model is not applicable. That is why we have to go for the machine learning and deep learning model, which is more powerful for handling the high dimensional data. And also it is very powerful to learn the relationship between the nonlinear relationship between input and output. So now, I have observed that in this domain of forecasting, is most of the work, research work, is actually nothing but a supervised learning. So Professor Dr. Sarkar has already mentioned that what is the meaning of supervised learning. Okay, so I am not just repeating the same thing. In supervised learning, the target is to map between the input and output, and the input and output, the data should be represented in this format. Just to look at this format, the data should be represented in this format. This is the input and this is the output. And this is the input, this input-output pair that should be given as a training data to the model, and model will automatically learn the relationship between the input and output and how this input and output are actually related. That will be automatically learned by the machine learning algorithm, and the corresponding model will be given as an output. So it will be, I have seen that most of the forecasting model are actually regression problem, and there are some. So now I am going to a framework of a machine learning model. Just to look at this, the traditional machine learning model. So this is a training data set that you are providing to the model, and the training data set is nothing but a pair of input-output pairs. And you are submitting the input-output pairs to the machine learning model, and there is some preprocessing that should be done on the input. And then there is a feature representation or feature extraction, and then the data should be represented to the input vectors, and the feature vector should be labeled. Corresponding label should be given, and then the training data should be prepared. And this training data should be provided to the machine learning algorithm, and machine learning algorithm will give us a trained model. During testing time, the test data, that should be again go through the preprocessing, feature extraction, and the vector conversion, and that will be submitted to the trained model, and the model would predict the output value. So this is the architecture, or this is the framework of a traditional machine learning model for the energy forecasting. So now I will little bit give you some examples on the different phases of that. If you see that, what is the meaning of pre-processing? So data must contain some noise, because the world is not noise free. World is not friction free. Similarly, the world is not noise free. Noise must be there. So you can handle the noise in some way, and you can remove, and sometimes the domain expert can help to identify what is the noise in the data and what type of data. Sometimes with the help of noise, and also there is some automatic technique, something like data clustering or that type of technique. We can also anomalous data can be removed from the data. Normalization is also very, very important. Data normalization, there are different types of normalization technique. One of the very simple technique is known as a mean max procedure. So you can subtract the mean value from every value and divide the value by the max minus mean. So this is the normalization process you have to do. In many cases, it's observed that some of the data are missing. So how to handle the data? How to handle the missing data? So it is not the wise decision to reject the entire example. So we have to fill up the missing data. There is some technique for doing that. Second point is the data sampling. Data sampling is very, very important, because if the data is not balanced, then sometimes it creates a problem. So data sampling, data decomposition, that I have previously mentioned, that your signal may be non-stationary. So sometimes it may be decomposed into a collection of stationary signals. So if we can decompose the non-stationary signal into multiple stationary signal, then we can apply the existing statistical model to the individual stationary data, and then we can combine the decision of those models together. So that this can be done. And the data augmentation. Data augmentation is a very important part, because in particularly electricity domain, as far as I can understand, that data is very limited. So limited amount of data is available here, and also data collection is a very, very difficult task. Nobody wants to publish the data, because data is a very private thing that is very authentic and private. So there is no regulation in India. I don't know whether is there any regulation in India to release the data, particularly thermal data or electricity data. So there is a very limited amount of data. So now how to work with the limited amount of data? So one of the technique which is data augmentation, and by that we can create the more data, and that can be added to the training. So now second was a feature extraction. The feature extraction or feature is a very important part, because you have to identify which feature is more important to differentiate. So now there are different type of features. In traditional machine learning, the features are handcrafted. Handcrafted means the domain expertise is necessary. So you need to consult with the domain expert, and domain expert can tell you that what type of feature is more important for your prediction. Just you take some examples. The different types of here in this particular work, Ibrahim et al. 2012, they have actually developed a solar radiation prediction model, and the feature they have applied the average daily maximum minimum temperature. This is the feature they have identified. Somebody can argue that this is not the features which is suitable for that. There are more features. You can think more feature. And another work in 2012, they have actually observed the historical data from the previous years, and the sunny day, foggy day, rainy day, cloudy day, and the different weather report that has been considered as features for the data. So for the model. So now the features, and they have developed the different types of machine learning model for forecasting the photovoltaic power output. So now after identifying the appropriate features and extracting the feature values, the raw input should be converted to the feature vectors. This is nothing but, feature estimate is nothing but a vector of the values of the features. So we have to collect the vector of the values of the features. And now You just go through, it is a summary of some of the work that I have identified and the features that has been used. So I have already mentioned the Ibrahim et al. And he has already used this type of features. And another work you see, the wind power prediction, that was a work is actually done in 2021. They have used the average wind speed, average ambient temperature. This too has been used as a feature for that. So now, this is a very interesting one. They have compared many machine learning algorithms, linear regression, logistic regression, loss of regression, elastic regression models. But the 21 different features they had extracted from the different weather conditions: humidity, temperature, precipitation, snowfall amount, cloud coverage, wind speed, wind direction, wind gust, angle of incidence, and different features they have actually applied. So now, since the 21 features they have collected, then they have applied a PCA. PCA is a principal component analysis technique by which the feature can be a 21 feature can be reduced to a certain set of most important significant features. All those features may not be important. Some of the features may be more significant. So how to identify which features are more significant, which are not? So PCA can help us to identify the more significant features from the given set of features. So, and finally, it can produce some uncorrelated features, which is obviously less than the dimension of 21. So in this work, they has applied this kind of features. So another work you see, the machine learning model, in this 2016, this work has been carried out. So they have used the hidden Markov model, and also they have used this model for short-term solar irradiance. I know that you know the meaning of irradiance, the power per unit area. So short-term solar irradiance prediction. So the different type of the features they have used, the solar and weather information collected using sensor. They have set up the different type of sensor, and that sensor data that is being sensor output actually used as a features. So now another model, the same research group, 2022, they have used the support vector regressor. Support vector regressor is another machine learning model, and they have used the two types of features: irradiances of sunny and no cloud days. So they have taken a series of days, some sunny days and some cloudy days, and they have calculated the irradiances, and this data has been collected. And using the data, they have trained a SVR or support vector regressor, and then they have been able to achieve the better performance than hidden Markov model. Although the hidden Markov model is a very interesting model for handling the sequential data, instead the SVR, they have shown that the SVR perform the better the SVM. So another work is 2022. They have used the two different model. One is a support vector regressor, another is a random forest regressor, and they have also applied for the short-term solar irradiance prediction. And they have also used the solar and weather information collected using the sensor. And they have also shown that the support vector regressor are performing the better than the random forest regressor. So in this particular work, it is clear in this small survey, the support vector regressor is a better model for predicting the different types of energy forecasting. So now I am going to the deep learning. So the deep learning is actually, if you have to say anything about the deep learning, I have to say initially mention the neural network. So a neural network is actually a category of machine learning model that are actually inspired by some biological neural networks in the human body. So it has a different components: input layer, output layer, and also the number of hidden layers. And ANN can be applied for classification and regression, but in case of forecasting problem, particularly energy forecasting problem, obviously we will actually rely on the regression ANN for regression problem. So now, what is called the deep learning? What is called the deep learning? It is nothing but a neural network. And according to the Andrew Yang, a ANN having more than 2 hidden layers can be called deep neural networks. So this is the basic definition. But in today's world, there are different sophisticated deep learning models are there. That is a convolutional neural network, LSTM, long short-term memory neural networks. That are the different types of the networks which is suitable for forecasting, energy forecasting. I will show you some example of that. So what is the actually utility of this kind of model? It can learn very complex relationship between input and output. By increasing the number of hidden layers, we can learn more complex function. So the complex function is nothing but a mapping from input to output. So actually this kind of neural network is actually can help us to learn the complex relationship between output and input and output. So now the complexity may be controlled by the increasing the number of hidden nodes and number of hidden layers. So that is the beauty of this model. So just to look at an example of neural network, how does it look like? It is actually a shallow neural network. It is a shallow because it has a 2 hidden layer. Just first layer is the input layer and second layer is the output layer, and there is a 2 intermediate layer. So this layer, this model can be trained using a algorithm. The name of the algorithm is a backpropagation algorithm. Using this algorithm was actually invented by Rumelhart and Hinton in 1986. And using this model, this model can be trained. So you have some input vector and you have some output vector. So if you submit some input and if you pass through the network, you will get some output. Now, by comparing the input and output, you will get some error. So now, depending on the error, you adjust the weight. And there is some forward pass and there is some backward pass. In the forward pass, you are submitting some input and you are getting some output, and you are comparing the predicted value and the desired value, what you want to have here. So you are getting the error. So depending on the error, you are adjusting the weight. Every connection has a weight. This connection has a weight, this connection has a weight, and this is known as the model parameters. So this model parameter should be adjusted through forward pass and backward pass, forward pass and backward pass. So after a certain number of iteration, or which is actually known as the epoch, this model will be able to learn the relationship between input and output. Now, whenever some test data will come, test data means you do not know the output, you know the input only. And whenever the test data will come, if you submit the test data here, it will give you the prediction. So this is the neural network, how it works. So the backpropagation algorithm is a very mathematically sounded algorithm. So this discussion is not there. So now another important aspect of the deep learning is the automatic feature learning. So I have previously mentioned that in the traditional machine learning, the features are handcrafted. You need some domain expert. But in case of deep learning, you don't do the handcrafted feature generation. You don't have any feature engineering. You have to submit the raw data to the model, and model will automatically learn the feature, and it will do this everything. So now you see here, it is a CNN. So there are it is known as a convolutional neural network. So convolutional neural network can be of 2 types. It can be 2D, it can be 1D. So 2D, if your input is 2D, then you have to apply the 2D CNN. If your input is 1D, then you have to apply the 1D CNN. So for the image analysis, we apply the 2D CNN because image is a 2-dimensional data. But forecasting, our data is a 1-dimensional. So since the forecasting data is a 1-dimensional, we have to apply the 1D CNN. So if we apply the 1D CNN, the CNN has a different types of layers. This is known as a convolutional layer, this is a max pooling layer, this is a flattening layer, and this is the neural network. So if the input data is submitted, there are different type of filters. The filters are actually work on the input to detect the features. The filter is nothing but a certain kind of window. This window will be set up on the input, and that will be actually applied on the input to detect the features. And after detecting the features, you will get, if you apply the multiple filter, you will get the multiple feature maps. And now all those features which is generated by convolutional layer may not be useful. That is why you are using some max pooling. What the max pooling layer is doing, the max pooling layer is picking up the more significant features from this group. So now after that you are apply the pooling. So you are selecting the more significant features from this section, then you are concatenating them together for flattening layer. So after flattening, you are getting a single vector, and this single vector should be submitted to the deep neural network. I mean, it is a fully connected neural network that I have shown you earlier, and then you will get the output. So obviously, that in case of regression problem, the output should be 1. The output should not be 2. It is a classification problem. Output should be 2, but there is some mistake here. In regression problem, the output should be 1 because it is a y value only. We have only one y value. So this portion is actually known as an automatic feature extraction, and this portion is known as a classification. So you see that in case of deep learning, that it is automatically learning the feature from the raw data. You are submitting the data, and this portion is actually learning the feature from the extracting the feature from the data, and this is the classification part that is actually applying. So now here's another model, the CNN LSTM model. So CNN LSTM model, you see there are another two kind of network. This is a CNN and this is a LSTM. So CNN is a neural network that is focused on the local information, and LSTM is a neural network which is known as a long short-term memory network that is more suitable for temporal data processing. I mean, in case of forecasting, the temporal information is very, very important. And the LSTM is very, very useful for processing the sequence data. So forecasting data is nothing but a sequence data, and the time is an important factor, and temporal information is an important factor. So using the CNN, we are doing the feature extraction, but using the LSTM, we are actually focusing on the temporal information. I mean, and long-term dependency. So that is why by combining this model, the CNN and LSTM, the performance of the forecasting can be improved. And this work, that the paper that I have mentioned in 2022, they have shown that by combining these two, the performance of the forecasting for solar PV output can be better than individual CNN model or individual LSTM model. So now, this is more efficient. CNN LSTM model is more efficient compared to the individual LSTM model, but it is overall their observation is that there are some situations, because there are, you see the 1 hour, 1 day, 1 week prediction. So there is a time frame. So they have observed that for some cases the CNN is better, and some cases CNN LSTM is better. So either CNN or either CNN LSTM model is actually performing better than any other model they have compared. And also they have compared the traditional models, I mean the statistical models that I have mentioned, and the physical model also with the CNN LSTM model, and they have observed that the CNN LSTM model is performing better for this kind of forecasting. So another deep learning model is actually known as the autoencoder. Autoencoder is also important because sometimes it is useful for reduction to reduce the dimension of the data. So dimension of the, whenever you are working with a high dimension data, the thumb rule is that if the data size increases, the dimension of the data increases, the model complexity increases. If the model complexity increases, the model will likely to overfit. So that is why we need to reduce the dimension of the data. So autoencoder is a deep learning model that helps us to reduce the dimension of the data. And in some work that I mentioned here, that is they have applied the autoencoder to reduce the dimension, and then they have fine-tuned the neural network. We are using that reduced data. So now another model is also I have observed some of the researcher has already used that is actually the ensemble. Ensemble models works better performance than shows better performance than the individual model. In ensemble model, the many models are actually combined together. So now there are the different types of common ensemble technique. So bagging, boosting, and stacking, these are the different types of ensemble technique. So the idea is that in case of bagging, so it is observed that the slight fluctuation in the training data, the model performance may be hampered. So any kind of machine learning model, slight fluctuation in the training data, the model performance may be hampered. So in bagging, so different instances of the training data is created through the sampling process. There are two types of sampling process. The sampling is actually known as a sampling with replacement and sampling without replacement. So sampling without replacement can be applied to create the multiple instances of the training data, and with the different instances of the training data, we can train the different models, and finally we can combine the decision. So it is observed that the variance of the model can be reduced by this process. So bagging is actually kind of ensemble model. It is a combination of multiple models, and that will obviously perform in many cases it improves the performance of the forecasting results. So so LSTM and CNN that I have previously mentioned, it is also a kind of ensemble model, because LSTM is a deep learning model and CNN is a deep learning model. So whenever we are combining the both, so then they are improving the performance. But whenever we are going to combine the different types of model, we should keep in mind that the model should be complementary. I mean, the one model will help other. So no, it is not that model A is better and model B is also better, and if we combine them, both will be better. It is not always true. So whenever we have to combine the model, then we have to think about that whether they are complementary to each other. So an excellent survey can be observed. You will find it is on deep learning and machine learning for power forecasting. It is available on the. So now the limitation and challenges. So I have already mentioned that one of the important limitation in power domain is a limitation of data. I mean the scarcity of the data. I am not sure that what amount of data is actually available in India. I did not find any website, and I did not find any website where from the electricity data or power data is downloadable for research. I did not find. Not only that, I have observed that there are different type of data exchange protocols. So I'm not sure about that, whether is there any data exchange protocol in India, and whether the government organization are thinking about that, because this power data is a very private data. So obviously data is a very big issue for developing machine learning model for any kind of power operation or power generation. So, and second one is a data quality. Data quality is very important. I am getting some data and without thinking about the quality of the data. So quality of the data should be obviously data should be quality. Quality data is very time consuming and difficult to collect, and data must be authentic also. And any deep learning model is actually data hungry. So if you don't have a huge amount of data, don't think about the deep learning model. So I have a small amount of data, 20 or 30 data. I am thinking to apply the deep learning model. So it is a wrong decision that you are doing. So if you have a huge amount of data, then you go for deep learning. So deep learning is a buzzword. So I have to apply the deep learning for solving my problem. Otherwise, the paper will not be published. That may be the motto. but that will not help in actual situations. So you have to collect data, or you have to generate data. You have to develop some protocol for collecting the data. I am not sure whether smart meter is permitted in India or not, and there is a many debate regarding the smart meter. I'm not going into that debate. So otherwise, how you can collect the data? How you are collect the data? So third, and data. Another point is that, and second challenge is that how to deploy the deep learning model is a real-time application. Okay, because in a laboratory, somebody can develop some forecasting model. It is working fine, but whenever it will be actually deployed in the market, how it will be integrated with the grid system, and how actually what will be the prediction, what will be the accuracy of that model, that sometimes varies. So the performance of the vaccine in the control environment and performance of the vaccine outside the environment is far and far difference. We have already know that what is the efficacy of the vaccine during pandemic period. So it is something like that. The deep learning model or the machine learning model that you are testing or you are developing in your control environment, and whenever you are going to deploy in the actual situations, the performance may vary, because there are some other factors associated with that may not be in mind at the time of designing the system. So now, another important problem regarding the deep learning model is that deep learning model is a black box. So what is going inside, it is not explainable. In a power system, there is some issues that need to be explainable. Why it is saying that it is better? Accuracy, say it is accuracy, forecasting accuracy is 90%. Why it is 90%? Particularly, one of the speaker has mentioned that to find the root causes. So if whenever you are going to find out the fault diagnosis, then we have to find out the root causes. So now we need the model should be explainable. So that is another important point. And in case of grid system, the external attack is a very, very important issue, because somebody or some external agency have the tendency to collapse the grid system. So if the deep learning model is going on or running, then it is very, very vulnerable to adversarial attacks. Adversarial attacks means a slight modification or minute alteration to the input data to make the deep learning model fail. So in that situations, this entire grid system may be collapsed. So now, whenever we are going to deploy the deep learning and AI, we have to be cautious. And another important point is time over. Okay. So another important point is that you should keep in mind, in a real-time applications or real-time power system implementation, I think that the collaboration between the industry and academia is necessary, because industry knows the power system. Academics sometimes doing some research. So those should both the groups should come together and sit together to find out the solution. Then only it can be fruitful. Otherwise, I'm not sure. So now, in conclusion, I can just want to mention few words that whenever the AI should be applied in any sector, initially that will lead to joblessness. Somebody will lose the job. Okay. So now my suggestion is that, or my recommendation is that, to identify the sectors where actually the AI should be applicable. Okay, why should be applicable? That region should be actually identified properly, and AI should be useful to empower the employees, not to replace the employees. This is my all.